These are sample problems for conceptual physics, Unit 1, Lesson 2. We're looking at Newton's laws. So remember the equation that we have is F net equals MA in triangle format. It would be F net equals MA. Okay? So determine the acceleration that results when a 12 Newton net force is applied to a 3 kilogram object and then a 6 kilogram object. So we're going to draw this. So here is, so we can use some logic to begin with. So here's my 3 kilogram object, and it says that there's 12 newtons. That's all I know that's on it. And then the other time it is 6 kilograms. So then I have a 6 kilogram object, and again that's kilograms, and it's being pulled with 12 newtons. So the first question is, which one's going to have more acceleration? So you can see this one has more inertia, right? So it's going to be harder to move, but you're having the same force you're applying to it. And so we can see from this equation or from the triangle that more M means more F net, or A means more F net, but if the F net's the same, if M goes up, A has to go down, right? M goes up, A goes down to keep that the same. This is an inverse relationship. M goes up, A goes down. So M went up, so A should go down. So we're going to make sure we think about that as we do this problem. So let's start with our guess method. So we're going to do given. And in my given, we're going to have F net equals 12 newtons. And then we have two cases. We have M1 is 3 kilograms. I know it's mass because it says kilograms. And M2 is 6 kilograms. So the kilograms, right, is telling me it's mass. The newtons is telling me it's force. Then I have my U, my unknowns, and I'm trying to find A1 and A2. And we already know from thinking about it that A2 should be smaller than A1, right? So then the equation, we have F net equals MA, or if we're doing triangles, we have F net over MA. So then we need to solve it. So if we solve the first one, we need to get A by itself. So we're going to divide both sides by M, and that will cancel out the mass. And so we're left with A equals F net over M. If you're doing the triangle, come over here, we cover up the A, and we can see it's F net over M. So then we know A is equal to F net over M. So then we're going to plug in the numbers. So we know we got the same equation on both. So A is equal to F net. Oh, but we got to do it twice, right? So let me give myself enough space. So we're going to have A1 is equal to 12 over 3, which is 4. We'll put that in the solve step. So let's put A2 is equal to 12 over 6. So that one is 2. Now, the hard part for this is not that. I'm just going to move this up a little bit. But when we saw, right, we have the solution, 12 divided by 3, right? 12 divided by 3 is 4. But look at our units. Newtons per kilogram? What the heck is, you cannot write a unit as Newton over kilogram. You have to remember that a Newton is a kilogram meter per second squared. So if I divide that by a kilogram, all right, which is what I did right there, if I divide that by a kilogram, the kilograms cancel, and yay, I have meters per second squared, because that's what I need to have, so meters per second squared. So that is A1. A2, on the other hand, is 12 divided by 6, which is 2, but it's the same thing, right? It's exactly like that. So it's 2 meters per second squared. And as we thought in the beginning, the more mass, the smaller acceleration. The mass went up by 2, so the acceleration went down by 2. Good, it worked with what we thought. Number 2, A net force of 15 newtons is exerted on an encyclopedia to cause it to accelerate at a rate of 5 meters per second squared. Determine the mass of the encyclopedia. So I've got an encyclopedia, and we know we have a net force of 15 newtons on it, and we know it's moving. Notice this is not going to be on the free body diagram. It's moving at 5 meters per second squared. So in my given, I'm going to have F net equals 15 newtons, and meters per second squared, I know that's A, so A equals 5 meters per second squared. My unknown mass, M equals question mark. My equation, same ones I had in the last one, F net equals MA, or the triangle F net MA. So then when I'm solving on the left side, I need to get M by itself, so I'm going to divide both sides by A, and the A's go away. So then I'm left with M equals F net over A. With the triangle, I cover up the M, so I see it's F net over A. So I end up with A equals F net over, I'm trying to solve for M. Sorry, let's fix that. I covered up the M. M equals F net over A. So it's the same equation, right? So then when we're solving, right, let's finish solving before I put solution, because I don't know what the solution is yet, because I got to plug in the numbers. So M is equal to 15 newtons, move this up a little bit, divided by 5. Divided by 5 meters per second squared. So I can see that I'm going to have 15 divided by 5. So 15 divided by 5 is 3. But then we're back to this weird unit thing, right? Newtons over meters per second squared. So again, I know a newton is kilograms meters per second squared, and I'm dividing by a meter per second squared. So cancels, left with a kilogram, which is good because mass is in kilograms. So M equals 3 kilograms. Yay! All right, next. A 5 kilogram block slides across a table at a constant velocity if it requires 3 newtons of force to stay at this velocity. What is the force of friction between the block and the table? What is the acceleration of the block? Oh, this one is a thinking question, right? Because we have this 5 kilogram block, 5 kilogram block, and it says it's staying at a constant velocity. So that means constant velocity, that's code. You see that word? Constant velocity. That's telling me what? It's telling me that A equals 0. It's telling me F net equals 0. There's no math. I just know that that's going to be 0. So if it's a 5 kilogram block and I'm pushing it with 3 newtons, then you could see that F net wouldn't equal 0. So you know that the force of friction, which is going the other way, so here's my force of friction, has to be equal to 3 newtons because that's the only way I can make it cancel, right? So if I have 3 newtons going to the left and I have 3 newtons going to the right, then my net force is 0. So I don't really have to do any math. I can just say F is 3 newtons. Make sure you drew the picture to show it. And that A equals 0. Done. Oh, we like problems like that. Last problem. Eduardo applies a 4.25 Newton rightward force to a 0.765 kilogram book to accelerate it across the tabletop. The friction force is 1 Newton. Determine the acceleration of the book. Okay, so we're going to draw a picture. So here's my book. And we know he's pushing with 4.25 newtons this way. But it says the force of friction is 1 Newton. So that's going to go the opposite way because it's moving in that direction. So friction has to go opposite, so there's my force of friction. And this one, remember, would be called my applied force, or just F. Right? It doesn't really have a special name, but force of friction. And the force of friction would be 1 Newton. Okay. So I can see in this picture that my F net is going to be this one minus this one, because they're pointing opposite ways. So it's going to be 4.25 newtons minus 1 Newton, which is easy math, 3.25 newtons. So that's my F net, which is what I needed. So in my given, I'm going to have F net equals 3.25 newtons. And then I also know that the mass, kilograms right there, mass is equal to 0.765 kilograms. And my unknown that I'm trying to find, what am I trying to find? Determine the acceleration of the boat. Okay, so that would be A. And then what equation? Well, we only got one equation, so F net equals MA triangle, bad triangle, F net MA, yeah? And so when we're solving, we have to solve the one on the left for A. So we say, okay, I want A by itself, so I divide both sides by M. We did that before. So as we're solving, we end up with A equals F net over M. On the other side, we know we cover up the A, so we end up with F net over M. So we have A equals F net over M. Now we can start plugging things in. So we have here that it's equal to A is equal to F net, which was 3 point right here, right? 3.25 newtons over 0.765 kilograms. So we plug that into our calculator, 3.25 divided by 0.765. And for our solution, we get 4.25. 4.25. And the units, remember, Newton over kilogram. So that would be kilograms, meters per second squared over kilograms, meters per second squared. So it's 4.25 meters per second squared. Now technically it asks for acceleration, which has direction, right? And so if we go back up here and we look, we can see that the net force is to the right, or in the direction of motion. It says rightward anyways. Edward applies a 4.25 Newton rightward force, so the acceleration would be 4.25 right, because it's going in the direction of the bigger force. So that would be my final answer. The rest are on your own.